People always dribble in late. You can't wait forever.
Okay.
So your department.
True.
That's how it works.
All right, guys. So, welcome to tonight's F-Sharp user group. I'm Reese. I've been working with F-Sharp for about a year in my spare time. I absolutely love it, and I get to tell all you guys about it. So if you'll bear with me, I don't actually have a mouse, so it should be fine. But if I'm a little slow at some points, I'm really sorry. So some of the sweet spots and benefits. Algorithmic analysis of large data sets in technical computing. That's one of the big reasons that F-Sharp gets used. Anything that uses units of measure. Scientific computing, gaming, finance, search engines. I know there's a ton of financial applications they're using F-Sharp right now, especially in the city. One of the benefits, code exploration. There's a separate F-Sharp interactive window at the bottom of Visual Studio. You highlight your code, which I will be doing a lot of tonight, hit Alt-Enter, and it runs all the code. So you can just sit there and explore and try to work something out, make sure you have all the right logic before you actually go and compile your code and put it into your library. That's been really great. I worked with Python for just a teensy bit of time before this, and it's a lot like doing that. It's just very scripty feeling. There's a lack of bugs, and this is hard to sort of describe why, but because of the way functional programming works, because of the way it's been developed in it and the way that you should be using it, there aren't edge cases, there aren't silly reasons that it fails. It's a lot easier to read and to maintain. There are tons and tons of examples and that you'll see online where there's 3 lines of F-Sharp code to create something and 40 lines of C# to do the exact same thing. There's all these extra parentheses and there's just it's like this long and there's 1 line of F-Sharp code that does the exact same thing. It's beautiful to look at. It's easy to read. It's easy to understand. It's great. The F-Sharp is functional, but it's still interoperable with .NET languages. So you can write a C# front end and use F-Sharp for your back end. So you don't F-Sharp isn't great for some of the GUI stuff, but you don't have to use it there. You can mix and match as much as you need. And then parallelism, and I specifically put that last because that is really great, and that's one of the reasons that I've seen a lot of people come into functional programming, but it's not a lot of the reason people stay in functional programming. It's definitely an amazing thing to use and to do, but it's not what keeps you motivated and fascinated by, or me personally, functional on a day-to-day basis. And the big thing at the bottom, F-Sharp is not just about lambda syntax. So it's one of the things I wanted to know from you guys. Who here has actually worked on production F-Sharp code? Awesome. Almost no one. But also pay attention to who those guys are, so that when you guys come back, you can ask them your questions. Who here has basically never seen a line of F-Sharp before at all? Awesome. Okay. And then the rest of you guys have been to a few talks, looked at it a little bit, played around. All right. The rest of you are just nodding. Somebody give me an experience and I will tell you, give you a sticker.
Day of F-Sharp, or 2 days of F-Sharp, that Richard put on, basically, about 2 months ago.
Yes.
You were there.
Yes. Okay.
I forget what that was called.
You're welcome. So I tailored this to people who've almost not even seen F-Sharp at all. And one of the big things that sort of scares a lot of people coming into functional programming is immutability. This means that everything that we would call a normal variable in object-oriented programming is not. It's basically a constant. It's immutable. The purpose, or maybe not the purpose, but one of the reasons is to make functions in programming more like math functions. programming x equals x plus 1, that's totally reasonable, that's totally fine. That is the source of a lot of bugs. You go to check on a variable later, and it's not what you think it is because you're an idiot. You did something that you didn't realize you had done. But, in math, sine of pi over 2 or sine of 90 degrees, that's always the sine of 90 degrees. I think it's 1. I think it's 1. But it's always exactly the same thing. You check on it, it doesn't change. 1983, it wasn't something different. And so that takes away this whole class of bugs that can happen. And it's, like I said, there just aren't side effects from that kind of thing. So that's one big thing I wanted to point out, that it's just a different way of thinking. And that's because we're trying to model it after something very mathematical. Do you guys have questions? Jump in. And I'm going to go to Visual Studio. Aha. All right, so F-sharp will automatically, it is statically typed, but it will automatically figure all of that out for you. It's sort of like var, using var when you use C#. Here there we go. So if I hover over the n, there we go. It tells me that n is an int because I'm setting it to 5. Let is how you set a variable. 5 is an integer. It's always going to be an integer. If I try to set n equal to 4, it should complain because it's immutable and it's not going to like that. Oh, that's what it does. Yeah, because I'm wrong. So it tries, because n is equal to 5, instead of trying to set n equal to 4, it basically says, well, n is 5, and that doesn't equal 4. So that's a Boolean and it's false. It evaluates it. Oh, I hit Alt and Enter. Yeah, so you highlight the code, hit Alt Enter, and it comes up in the window at the bottom. But for those of you who came in late, I told everyone earlier that I don't actually have the mouse with me, which is why this is complicated. So when I try to invert this and do a 1 over n, because n is an integer, I have a float in there. It gets very angry with me and shows up. Type in does not match a float. So it won't let you change something if it does that, if it already declared what it is. But the next thing, I let the square of y equal y times y, simple function, then it'll do the same thing I promised you where it thinks it's an int. There we go.
Why would it think it was an int?
Because that's the basic number. There's no reason to think that it should be a big int or a float. There's no indication there. It does, squaring or multiplication involves 2 numbers. So it definitely is it knows that it's 2 numbers, but it's not going to try to square 2 strings. But
Okay.
There's no reason to think that it needs to be anything other than an int.
So if you try to square a 5.0, will it
Yes.
throw an error?
No, it won't.
Okay.
Here, when I change that, because you didn't specifically declare an int involved in that, when I do a 1.0 over the square of this, it now updates the definition to a float automatically. So if you later give it reason to update the definition, it will do that, which is amazing. It handles all of that for you, which is also is wonderful and kind of a pain. I spent a lot of time when I was first trying to figure it out with just trying to make the units line up correctly, which was really good. And I read somebody's blog just a few days ago where they actually made the comment that F# is either completely blowing up and nothing works, or it's exactly right and like it doesn't fail. And that just seems to be true. Once I get all the squigglies to go away, that's the code I need. There isn't a further bug in there because I was dumb about the logic. There just isn't.
You could be explicit about this, right? You could simply say y is not an int, but it is a float.
Yes, you can say, can I do some of that? Oh, okay. You can say colon float. And then y, it'll know it's a float from there on. And in some cases, you do have to do that to make sure everything works out correctly. And I have done that in some of my later code.
Rachel,
Yes.
previously when n was 5, which is an integer, when we tried to do inverse, it wouldn't work because it needed a float. Can
Right.
we do something similar to the cast that we have in C#?
You can, I believe that,
It's okay, you don't have to show flash.
I have an example down later, which I know I've done, and I think you just put friends around it and do the colon, but I don't recall offhand, and I know it'll be there later. So the way you declare lists is just in brackets, first number, 2 periods, last number. Very simple. If you need a step in between, evens, starting at 2, every second number, that'll be 2, 4, 6, 8, 10. You can run this. It just creates the 2 lists. A very simple let plus 3x equal x plus 3. Very basic. Then you start combining these things. We have the let list plus 3 function map a list that you get in using plus 3. So you can send in the argument if you wanted to, or you can just declare a new function that acts in this manner. Run these two. You'll see that the plus 3 takes an int and goes to an int. So it takes whatever x is and it adds 3 to it. Whereas the list plus 3 takes an int list and sends back an int list. So it takes in an int, it takes in a full list, adds 3 to all of them because of the mapping. But you can also use anonymous functions. So the x%2 is a modulus function, so everything that's even. And it'll filter out the list that you send in to just include everything that's even. So if we declare that, then it has the same signature as the previous one. It takes a list and it finishes with a list. And then there are 2 different ways that you can combine all of this together. You can use what's called pipelining, which is actually tons of fun. Yes?
How would you read the previous line?
How would I read it?
Yes.
Um,
The last part. Font x.
Function x, what I usually say, and I don't know if that's right, but function x goes to x modulus 2 equals 0, but it's, I guess where is what the arrow would, you want to filter the x's where x modulus 2 is 0.
It returns something.
It what?
Sharp functions always return something,
Even
so
if
in
it is
this
a
case,
function.
it returns a comparison between x modulo 2 and 0. So really it returns a blue.
Right.
So what you're doing is a filter based on a question.
So there are 2 different ways that we can run this. We can use what's called pipelining, where we start with the list that we want to modify, and then we pipe it into the filtered function, which will filter it into everything, all of the evens, and we can add 3, and then we can filter or pipe that into the sum function. So that'll take all of the evens, add 3 to them all, and then sum them. We hit Alt, enter, we get 45. Or we can use function composition and take the functions and map the 3 functions into another function first. So this is taking filtered, like f of d of x, you guys remember your math, filtered, composed with list plus 3, composed with the list sum, is the function now sum evens plus 3. Then I can use the one single sum evens plus 3 function to run all 3 functions in a row. Does that make sense?
It's a function of a function of a function.
Yes, exactly. And then I'm saving that as another function. I started out using the pipeline syntax because it was much easier for me to understand. The function composition is something that I've just started realizing can easily be substituted in. So it's, yes.
Sorry, what is the significance of the indentation from 24 to 25?
Thank you. So first of all, F# does have significant white space. So rather than having, all of the brackets that you see in C#, you just indent something, and when you unindent it, it knows that the if statement or the method that you're calling or the new function is finished. So from 24 to 25, I guess you don't have to indent when you pipeline. I think it looks a little better, and it's easier to understand that it's that this list is being sent into these pipelines.
I have squigglies when I didn't indent the after result equals after if I didn't break that into different lines.
From 23 to 24, from the let result equals to the list bracket, that one you have to indent, because that let result is the start of a new function, and so to display that everything is in that function, you have to indent there. Does that make sense?
There's no line delimiter, like a semicolon or an
Nothing.
enter key?
Nothing. And the way, which is, it's very, very super minimal. One of the really cool things is the way that you actually return something from a function, which I'll even show a little bit later, but is to just write it at the bottom. So if the value that you need to return from a function is 7, just the number 7, you just write 7 on the very last line, and that's it. You don't have to say return 7 semicolon, none of that, you just type 7.
Is it possible to do multiple returns for a function?
What?
Is it possible to do multiple returns from one function?
It is, you have to, you have to, I think, put commas between them. You can return tuples, which is easy, but,
And what I mean is a 2 points in a function.
yeah, it's, if you just have 2 return values, then you just put the first one, comma, the second one, comma.
But a
It
condition,
means returning from a function in two different places with return and then.
Oh.
one value or another.
So, yeah.
It's, no. Every value in F# is an expression, which means everything has to return some value, which means your function has to return some value. You can return from multiple places in a function, but you would have to be returning the same type of value from both places.
So you use the if expression.
Yeah.
As a return.
Yeah, but both of your cases have to agree.
Rachel? The function in 23, or the result of 23,
Yes.
in 29, there would be, not identical, but the similar result. Even internally, one is pipeline, take the result and type the result function. Well, second one, you have the function of the function of the function, but
It's
plus
exactly the
is
same.
that, yes.
Yeah. And I'll run all of them. So 45 and 45. So this actually, I'm just returning, I guess I'm not really returning since it's not even a function, but sum of evens plus 3 of the list 1 to 10, the bottom line 33. That I'm saying just, evaluate that. But yeah, they are exactly the same.
Just go back to the definition of filter for a second.
Sure. To what?
The definition of filter.
Oh, sure. There we go.
a question about, on line 18, so is that just, declaring a function basically, it's not declaring any variables?
No.
Okay, X is just strictly the parameter, it's not a standalone, okay.
Wait,
It's not a standalone variable,
Yeah.
basically, okay.
and you do both with let. So you can just say, let x equal 7 or let plus 3 of x equal x plus 3. It's all the same.
Okay,
Help?
so it's plus 3 actually variable too, the type function or something?
The function is x plus 3.
Right, okay,
And it takes in the value x, whatever you send it in.
okay.
Is that-
Yes, I'm thinking in the JavaScript world where you can have a variable and you can just assign anything to it, you can assign a function or a number or, whatever. Fair enough.
So then we get into and I'm not actually talking about list heads and tails here. So recursion and matching. So to declare a recursive function, which is one of the best ways to do anything that you would have done, like a for loop on anything like that, then you just need this rec keyword, which declares the function as recursive. Otherwise, it doesn't know. Factorial is the super easy example, and I had actually, well, I'll do it again in a second. So, factorial of x, match is similar to a switch case statement. It'll take in a value and match it with other values. You match x with, I actually wanted to do 1 here because that would save a loop. So match x with 1 when the factorial of 1 is 1. And the underscore is a wild card. So when it's not 1, when it's anything other than 1, you match that with x times the factorial of x minus 1. And the other thing I had added in here was a statement for when x is less than 0, then match it with 0. Really, I would like to return the string undefined, but I can't do that. So when x is less than 0, the factorial is undefined. But there's also this thing called somebody say okay. What? Yeah. So you can have like an if statement before you're matching. What are they called? Bridges, orders, guards. Free association. And you can basically like guard the value. So I want to match the underscore, meaning wildcard anything in the world, but only when x is less than 0. So it sort of guards passing back that 0 value. Makes a lot of sense. And then finally, if it's non-0 and it's not 1, or if it's not less than 0 and it's not 1, then do the factorial and send it down. And then you run the factorial 5, it's 120. And if you try to do factorial of minus 5, it's 0.
Would you be able to return a negative infinity like you can do in C#?
That I don't know.
Okay. Fair enough.
It's an integer. I mean, you couldn't return negative infinity because that's not defined in the integer space, but.
Oh, you're right, you're right.
What's the underscore do there?
It's the wild card. This right here,
Right.
that's not being highlighted, even though it should be.
Sort of like the default. That's
Yeah.
Everything else.
It's like a case else.
So, but then, okay. That's two case also.
So the first case else is only when x is less than 0.
Okay.
So it is a wild card, and the first one, that's what I was talking about, the guarding. So it's guarded, and so it's everything when x is less than 0. And then the other one is really, really actually everything else.
What happens when x is 0?
It. Question.
So it returns 0.
Yeah, it'll return 0 because it'll return the factorial -1 first and then go through. Because I forgot that case. I can add less than or equal to. Yes. Yes.
I don't know if you can answer this, I'm getting a lot of blue squiggles that say this expression should affect me, that, Dr. might know offhand with that.
If you assign it to something, you can do with.
It's you're not defining it quite right. Double check that like you're yeah. And even if you want to go back and talk to one of those guys, or I can help you out after the talk. Sorry.
Okay.
So then the other thing we can do with matching is this sum versus none thing, which is really kind of awesome. So we can do, this find number in a list. We can try to find in an anonymous function that, where x equals 4, looking for the value where x equals 4 in a certain list. We match that attempted find with either sum, because it found something, or none, because it found nothing. And so if it matches something, it'll print that it found something. And if it matches nothing, it'll say so. And so we try to find 4 in both the list 1 to 5 and the list all the odds from 1 to 15. It'll find it in the first one, but not in the second. So found 4, nothing's happening. And that's the sum and none is really super powerful. The next thing, the sequences. It comes up a lot, at least that I've seen here. The Fibonacci one is a sort of almost stereotypical example, but this was some of the first F-sharp code I even saw, and it, 1, totally baffled me, and 2, I loved it. I had started to try to solve the project Euler problems. There's a whole website of just really basic math problems, and some of them use things like the Fibonacci sequence. So this will just unfold the entire infinite sequence up to the point that it needs it. It'll do I guess what's called a lazy evaluation. Yes.
What is the name of the website?
Project Euler. EULER. I think it's PROJ Euler.net. It was one of the things I had to add to my slides and didn't. So I'll find that. But yeah, they're really just the sum of the squares of the numbers less than 100. I think is the first one. And they get really quickly. They get much harder, but it really, since math problems are such an easy functional lends itself to math so easily and so well, it was a great place to start for me. So what this is doing is it's taking a sequence, unfolding it. This sum here is basically a matching, except in this case, because we're sending in something, we don't have the matching to none case. So we're taking 0 and 1 and sending that into the function where it's a plus b and then a new set where it's b comma a plus b, and it will just evaluate each new tuple as it needs. And then you can do something like find the 10th, so it's equal to and number 10 Fibonacci, and it'll print 144. So it evaluates up just to the 10th thing in the sequence and gives you back that one. So it's one super handy for things like Project Euler, but really I haven't seen this in any other language. It may happen, it may be there, but so impressed by something like this. And then we get on to currying. And I don't know if my example is a little too mathy, but I was kind of happy with it. So what I'm doing is, there are these things called metrics, which are really just distances. And there are, what currying is sort of partial application of functions. So if a function takes two variables, or two arguments into it, you can declare a new function which has one of the arguments predefined. It's, so if you had, we'll use this one. So, in this case, this is what I wanted the marker for, which I haven't. The distance between 2 points on the line, is x squared minus y squared square rooted. And that will find the difference for you. There's also this thing called the Manhattan distance, which, if you think about how you get around Manhattan, it's all in blocks. This way, and then this way, and then this way, and then this way. And that's a different measure of distance. So these two formulas, which are both, the square root of the squares and the going over like this, these both come from the same generic formula, which is the Minkowski one right here, which is basically, well, I'll scroll down and then, I updated, I thought I was going to be able to use my Mac, and so I updated some of the code in the other one. Sorry, so it's basically the absolute value squared, and then you sum these and take the square root of it. In the case for the Manhattan distance, you don't need to square root it and you don't need to square it. It's basically, you send it to the power as 1. I know this is probably too much math for one day. I'm so sorry. But what this does is basically, you have this one generic formula that starts off. And then you have the two much easier formulas down here where the case when P is 1 and the case when P is 2. So I've just preset P as 1 in the first case, the Manhattan one. The second case, I preset P as 2. But I ignored the two list parameters just completely. I didn't list 1 and list 2. I didn't define. I didn't say anything about them. It's, they will come later when I call either Manhattan or Euclidean. Does that make sense?
Yes.
Okay, good. And another comment that I wanted to make about the very top line, number 59. When you're mapping lists, there's like 6 different list map functions. This one in particular takes 2 lists in, and it'll just subtract them. But list.map2 takes 2 arguments. So, like the previous one where I was adding 3 to all of the values in the list, this one I'm actually taking 2 separate lists and subtracting all the values. So you can act on more than one list at a time. Yes.
Are you saying that you can pass partial parameters to this thing?
Yeah. Yes.
What's the 2 stars?
The what?
On line 63 at the end, X star.
Oh, that's x to a power. I only just found out about this recently. And ADS is the absolute value of x to the power. So there are actually 2 different functions. There's the star star and there's pow or pow n, I think. And one is just for integers and one is for everything else. So that's something interesting. So we declare all of this. You can see it, because there's a bunch of parameters, it does some pretty crazy things. When we declare Manhattan Euclidean,